Our switches are designed to forward frames at a really high rate of speed using application-specific integrated circuits known as ASICs for short. In order to accomplish this, the information needed to forward the data at that really high rate of speed needs to be stored in hardware. It needs to be stored in these application-specific integrated circuits. And this is where the CAM and TCAM come into play. These are memory tables in hardware that ensure our switches can forward that data at a very high rate of speed. So CAM stands for Content Addressable Memory, and TCAM stands for Ternary Content Addressable Memory. Where does CAM come into play? CAM comes into play when we are dealing with MAC address lookups. So you can think of this CAM table as the MAC address table. You could use those terms interchangeably. Notice how CAM and MAC are simply reversed. Well, inside this content addressable memory, we find the MAC addresses. We find the ports that the switch can utilize to reach those MAC addresses, in addition to the VLANs associated with the specific ports. It's important to realize that this CAM operation is an exact match operation. An exact match operation. What do I mean by exact match? Well, we're dealing with binary ones and zeros. That MAC address gets converted to binary ones and zeros. And the lookup is looking for that exact sequence of binary ones and zeros when making a decision. So there's no variation. When the switch is looking at that MAC address, it's looking for that specific MAC address. If it doesn't find it, it's going to flood out. It's going to flood the frame out all ports except the port it came in on. If it finds an exact match, it forwards it out the appropriate port. However, there will be times whereby we don't need an exact match. We are simply looking for the best match, the closest match. This might be with access control lists or quality of service or the routing table. How does the routing table work? The routing table is simply looking for the longest match rule. We have the IP address 10.1.10.10. As the lookup occurs, does this /32 entry match? Nope. Does this one? Nope, 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 nope. It just simply goes down through to find the best match. As soon as it finds the best match, that's a hit. Now, is that 10.1.10.10? No, it's not. It's 10.1.10.0. But it falls within this best match of 10.1.10.0/24. So that's good enough to complete the task that is required by this device. So with TCAM, ternary content addressable memory, we're dealing with those binary ones and zeros, so exact matches, or I really don't care. That's what the X stands for. It's the don't care bit. It could be anything else that would still allow us to fall within that particular range. So here, the last octet and that IP address doesn't really matter because the IP address would fall nicely within that range and everything would work well. So we have these two different tables. And it's not necessarily two tables and only two tables. We can have multiple TCAM tables. You could have one for the ACLs, one for QoS, one for routing. So there might be multiple TCAMs on the device. But it's important to realize that CAM is going to be a perfect match when it looks it up. Where TCAM, it could be a perfect match, but if it's not, the best match is found to make the forwarding decision.